This is Module 8, Number 5. A traffic safety company publishes reports about motorcycle fatalities and helmet use. In the first accompanying data table, the distribution shows the proportion of fatalities by location of injury for motorcycle accidents. The second data table shows the location of injury and fatalities for 2,087 riders not wearing a helmet. Complete parts A and B below. So just to kind of explain this a little bit, we have two data sets. One is the location location of injuries based on fatalities for motorcycle riders wearing a helmet. The second data set is that they're not wearing a helmet. So we kind of want to compare, like, does wearing a helmet really have an impact on the location of the injury for fatalities in motorcycle accidents? So let's look at part A. Does the distribution of fatal injuries for riders not wearing a helmet follow the distribution for all riders? Use alpha equal 0.01 level of significance. What are the null and alternative hypotheses? So again, remember that the null hypothesis is that the distributions are the same. The alternative is that they're not. So let's look. So here, part A, the distribution of fatal injuries for riders not wearing a helmet follows the same distributions for all riders. We can just double check. Part B says does not follow. So we know that we want them in the null hypothesis to be the same. The alternative is for them not to follow the same distribution. Let's check that. Nice work. Okay, so for the next part, we need to come up with the expected count. So let's use StatCrunch to do that. So we could either manually calculate and multiply the probability or the proportion of those wearing a helmet times the total number, which was 2,087, or we can use StatCrunch. So let's go through how to do it in StatCrunch, kind of like how we did in number 4. So let's open the data set. Again, here's the probability. Those are based on people wearing a helmet, motorcycle riders wearing a helmet. The frequency is without a helmet. So let's go to Data, Compute, Expression, click Build. Okay, so we're going to do probability, probability, add column, times, was it 2,087, is that right? 2,087, yes. Okay. 2,087. Click OK, and then compute. Again, we get the message just letting us know that extra table was, that extra column was created. So here we have the probability. So let's go ahead and put this over here so we can have them side by side. Okay, so here we just need to get these values in here and they line up. You can see the location of the injuries here. So for multiple locations, our expected count is 1,189.59. Then for the head, it's 646.97. For the neck, it is 62.61. For the thorax, it's 125.22. And for the abdomen, lumbar spine, the core there, we have 62.61. Now remember, our expected counts are not going to be whole numbers. We're multiplying the probabilities by the total number. So we're expecting to have decimal places here. So let's go ahead and check answer. Nice work. So here, what is the p-value of the test? So now we have our observed here in frequency and our expected here in that probability multiplied by the 2,087. So let's go to goodness of fit, chi-square test. Observed is frequency. Expected is that probability multiplied by the total number of motorcycle accidents. Here our p-value is less than 0.0001. So I think we can just put 0.000 here. Check answer. Okay. So based on the results, does the distribution of fatal injuries for riders not wearing a helmet follow the distribution for all riders at a significance level of alpha 0.01? So again, if p-value is less than alpha, we reject the null hypothesis, which is the case. So we already know it's going to be B or D. So we can read the rest of there is sufficient evidence that the distribution of fatal injuries for riders not wearing a helmet does not follow the distribution of all riders. Well, that was our alternative hypothesis. So we know that's the answer. Excellent. So compare the observed and expected counts for each category. What does this information tell you? So here we have the options are motorcycle fatalities from head injuries occur more frequently for riders not wearing a helmet. Thorax injuries occur more frequently for riders not wearing a helmet, or head injuries occur less frequently. So let's just go take a look up here. So the thorax occurs less frequently for without a helmet. The head appears to occur more frequently without a helmet than it does with a helmet, which is what we would expect. You would expect to get more head injuries if you're not wearing a helmet in an accident. So we're going to click A, final check. All right, that's how to do number 5. If you have any questions about that, about any of the problems, let me know.